right, so we plug in. That's always our first step. The issue is when we plug in, we get 1 over a minus 1 over a over 0. So we're looking at 0 over 0. So when we get that 0 over 0, we need to factor and we need to cancel and then plug in. And this cancel step is really the crucial step. How we get to cancel is kind of up to us. Usually we factor, but we need to figure out how to cancel. And specifically because h is going to 0, remember that arrow becomes a minus sign, h minus 0 is what we are trying to cancel. So our goal is to cancel out an h in both the numerator and the denominator. So the good news is that we do have that h in the denominator. The bad news is we don't have that h in the denominator currently, or in the numerator currently. So we got to figure out a way to get an h factor to appear in this numerator, what's above the main division line. So if you look at the previous question, number 97, we did some simplification on the numerator first. So before we factor, we got to try to simplify as much as possible that numerator, because right now it's a hot mess. It's a fraction minus a fraction. So if you have a fraction minus a fraction, we have to get an LCD. And if you look at our LCD here, the a plus h denominator is a whole separate factor from the a denominator. So those are two separate factors that we're going to have to involve in our LCD. All right, so let's go about getting that LCD. So for the first fraction, again, we're trying to get this as our LCD. For the first fraction, we have the a plus h factor, but we need the a factor. So we'll multiply the first fraction by a over a minus the second fraction. We do not have that a plus h, so we'll multiply by a plus h. But we do have the a, so that is good. Okay? And then this is all over our h. Now, the whole point of this was to get an LCD. So now that we have this LCD, we are going to rewrite it as limit as h goes to 0. All right, the LCD is a times a plus h. Again, the order that we write that in does not matter for us. 1 times a is going to give us an a. This negative 1 times a plus h is going to have to get distributed to both the a and the h. So this will be minus a minus h. So this numerator with the LCD is becoming this as the simplified numerator for now. And then we still have the h in the denominator. All right, now again, before we think about factoring, we've got to think, is this simplified as much as possible? And you look, you have an a minus a, so those can cross out, and that will leave us with the limit. Again, we still have the h, so we still have the limit notation, negative h over a times a plus h over h. All right, now we have a complex fraction here. So when we have one fraction over one fraction, it doesn't really look like one fraction right now because it's just h, but we could write that as over 1. If it's one fraction over one fraction, we are going to do the keep, change, switch thing. We're going to flip it around, and we're going to multiply by the reciprocal of the denominator. Okay, so we multiply by the reciprocal of this denominator. That gives us the limit as h goes to 0, negative h over a times a plus h, times the reciprocal of the denominator, 1 over h. Now, at this point, you could multiply straight across, but because you have multiplication, multiplication is going to undo the division. So now you can cross out this h factor with this h in the numerator. And that was our goal, was to cancel out the h minus 0 or just h. So now that it's canceled, things are looking up, and we're hoping that once we plug in, everything's going to be fine. We're going to get a finite number. So once we cancel out those h's, we have negative times 1, so just negative 1 over, and then a times a plus h. Now, what exactly are we plugging in here? What we are plugging in is h is going to 0. So that tells us, is h going to 0, tells us we want to plug in h is equal to 0. So we will have negative 1 over the a is still going to be there, the a is still going to be there, and now the h is going to be 0. So that will give us negative 1 over a squared as our limit. And it's perfectly fine in this case to have an a variable constant or what have you, an a letter because that was also in the original problem we had A's and H's. But the H is going to go to 0 because the H is the arrow 0. So we're plugging in H equal to 0 for our plug-in step at the end.